Hello. Before getting into these questions, let me first ask you one question. It's a fundamental of parabola. Let's assume we have a parabola over here. We have a parabola, right? This is a typical parabola, and we have two tangents on it. Two tangent. Okay, one is this one, and another is somewhere here. Let me see if I can draw right. Yeah, this is approximately this just touching here. Okay, but these two are the tangent. One is T2, another is T1. Okay, now my question will start. Is it possible to have one straight line in such a way that inclination of the straight line from this T1 and T2 equal? Let's give a try. We have one straight line. The inclination means the angle between the T2 and this line L is some angle. Then it is always possible to choose this line in such a way that you will get the same angle here. Means angle between T1 and line L can be equal. Means these two angle can be equal. Theta and this theta can be equal. Okay, means it is possible, right? There's no confusion here. Means we can have a two tangent on a parabola in such a way that these two tangent will make equal angle, right? Equal angle through line L. Okay, now my question will start here. The question says that a pair of tangents are drawn which are equally inclined to a straight line y is equal to mx plus c. Let's take this a straight line y is equal to mx plus c. Okay, and now whose inclination to the axis is alpha. Let's take this as an axis here. This one is my axis. Okay, and inclination to this axis is given as alpha. Okay, prove that locus of their point of intersection is a straight line. Means this locus of this point is a straight line. This we need to prove. It means we can have several such tangent, right, which can make equal angle with this straight line. Yeah, you can try. Like you could change T2 like this, right, and then change T1 accordingly, so that you will get the equal angle. Equal angle doesn't mean that the 30 and 30. Next time you can have 45 and 45. Another time you have 60 and 60. Means both angles should be equal. It is not necessary that this theta should always be same. No, that's not the question. It's like these two angles should be equal. That's it, right? Then take for example for this T1, we have alpha 1. For T2 we have alpha 2. Okay, then by simple geometry, you can say alpha 1 is equal to theta plus alpha. Okay, alpha 1 should be equal to theta plus alpha, and alpha should be equal to theta plus alpha 2, and alpha should be equal to theta plus alpha 2. Okay, now what you do, you subtract this 2. If you subtract alpha 1 minus alpha 1 minus alpha, theta will get cancelled, alpha minus alpha 2. Okay, alpha 1 minus alpha will be equal to alpha minus alpha 2. Okay, take this alpha 2 this side, or alpha this side, alpha 2 this side, whatever. You will get 2 alpha will be equal to alpha 1 plus alpha 2. Okay, now you take a 10 off both sides, then 10 to alpha should be equal to 10 alpha 1 plus alpha 2. Okay, now if you want to write it in better way, you write it here like 10 to alpha should be equal to 10 alpha 1 plus 10 alpha 2, 10 alpha 2 divided by 1 minus 10 alpha 1 into 10 alpha 2. Okay, now this yellow line means T1 and T2 are tangent, right? You know the equation of tangent in a parabola. Equation of tangent in the parabola, P equal to y is equal to mx plus a by m, right? For tangent 1 it will be m1, for tangent 2 it will be m2, right? So this equation is like y is equal to mx plus m1 plus c1, and this one y is equal to m2 plus c2. So if you take this as a means m1 as a tangent, and this one will be m2, then what you will get here? You will get very simple equation m1 plus m2 divided by 1 minus m1 m2. Okay, right, now our game will start from here. This is very important equation. This is the equation of tangent, and we need to find out the locus of this point, right? Our fundamental way to find the locus of any point is like you assume this point as a hk and try to find out the relation between hk in terms of constant, right? Then you put this hk value over here because this tangent is passing through this hk point, right? This tangent could be this or could be this. We will take general value of m, right? Then take as a general value of m, the k is equal to mh plus a by m. Okay, now what you do, you just solve this equation. You will get the quadratic equation in m. Okay, I will write quadratic equation in m here somewhere. Quadratic equation should be m square h minus mk plus a is equal to 0. Okay, then you have a two value, right? m1 m2 here, so you make m1 plus m2 should be equal to k by h, and m1 m2 should be equal to a by h, right? You put this two value m1 plus m2 and m1 m2 in this equation. What you will get? K by, you need to put k by h and a by m. Here you put it k by h by 1 minus a by h. Okay, what you will get here? K by h minus a. H will get cancelled, h minus a, that will be equal to 10 to alpha, right? Then you will get what you will get, h minus a into 10 to alpha. 10 to alpha should be equal to k. Okay, k is equal to hk, h is x, k is y. Just put this value, you will get the locus. X minus a 10 to alpha is equal to y. This is the locus of a point, this point, right? Means you will get this kind of point in several ways. If you change this t1, change this t2 in such a way that this make equal angle, then you will get some point like this, and this will be a straight line, and that is the locus of these points. Okay, see you in the next lecture. Bye.